Well, it means that this is equal to this.
Okay.
So
Maybe that's helpful.
So what else? We've shown that this part of the sides are equal.
Yeah. So we're getting pretty hopeful, right?
Yeah.
That we're going to get there. Now we just have to show the whole sides are equal.
Well, is there another pair of congruent triangles that might help us? Well, there's this triangle and this triangle.
Yeah.
But we don't know any of the angles except for the right angle.
We don't. But do you know anything about those triangles? What's special about any of the right triangles that you've identified so far? There's something special that you've forgotten.
Well, so like these right triangles.
Yeah, there's something very special about those triangles.
Well, angle 1 plus angle 2 I know is 90.
Yeah.
And their hypotenuse is the radius of the circumcircle.
Okay, their hypotenuse is the radius of the circumcircle. That's good.
And they're all right triangles.
They're all right. Why are they right triangles? How do we know they're
Well,
right triangles?
Because this angle bisector is the same distance away from both sides.
Okay.
And the shortest distance would be a perpendicular.
Yeah. Is there any other property about that perpendicular?
Well, we already said that those perpendiculars were the same.
Yeah. What's special about this point here? We've got to go all the way back to the very beginning of the problem. What's special about that point there, that intersection point?
So it's the same distance away from all three vertices.
Read the problem again. Right here.
The angle bisector of angle G of GHI passes to the circumcenter of GHI.
Okay. So what's special about that point?
It's the circumcenter.
It's the circumcenter. It's on the angle bisector and it's also the circumcenter. What does that mean?
It means it's the same distance away from these sides.
Right. That's because it's on the angle bisector.
Yeah.
Now, what else does it mean?
It means that... What else does it?
Yeah.
It's the circumcenter.
Okay, good. Which is what? What is the circumcenter?
It's the center of the circumscribed circle.
Yep.
It's the intersection of the perpendicular bisectors.
What does that mean?
It means it's the perpendicular bisectors they meet at a point.
Okay, draw me a perpendicular bisector in this triangle.
So like this is one.
Okay, so what does that mean, that that's a perpendicular bisector?
So it means it cuts the triangle into two equal bits.
Okay. Draw me another.
Well, that cuts the side into two equal bits.
Okay.
So.
Draw me another perpendicular bisector.
Oh, so this is also a 2. Because this is half the side.
What does that mean?
It means that the sides are the same.
Why?
Because these are perpendicular bisectors.
We already knew these perpendiculars. We knew from the beginning that these perpendiculars cut those sides in half. Okay?
Yep.
The one thing I would advise you is you didn't label that in the beginning. So you didn't label that this was equal to this and then this was equal to this. And that, not because you didn't label that, it caused you to forget that those were the same. So once you identified this and this as being the same, you were done. Right? Because why?
Because that means this and this are the same.
Okay, good job.